Okay, now let's try to understand this concept of the abstract keyword in Java, right? How it is used. Abstract is a modifier. The abstract is a abstract keyword is a modifier for okay, it is typically used for classes. Okay, it can be a modifier for methods and interfaces. Okay, as far as interfaces go, okay, all interfaces are abstract. Okay, so even if you don't mention, right? So even if you don't mention, it will still be considered to be abstract. Okay. So first thing, yes, it's a modifier for classes, methods, and interfaces. Okay, fine. Okay, so again about abstract class, what is meant by an abstract class? Okay, and why for interfaces we have it as abstract all the time? Okay, so if a type is declared as abstract, if any type is declared to be abstract, fine, then we cannot have instance of that type. We cannot create instance. There cannot be an instance of that type. You may be having an instance of its subtype only. Fine, instances, the objects which are created, right, by calling a constructor, we say new. Okay, that's allowed for anything which is not abstract. If you declare a class as abstract, oh, you won't be able to create object of that class. It's not that we won't have any object of that type. When I say type, it includes a subtype. See, typically, if you look at our example, what we have done, we have created a class called account. Okay, then we have the two subclasses, savings account and current account. If we declared account to be abstract, then what is the effect? You won't be able to say, oh, let me have a new account object, calling the constructor to create account object. Fine. Savings account, current account, they have not been declared to be abstract. Fine. So yes, you can create object of savings account and current account. Right? Typically, you don't just create an account, right? You would have it as a savings account, current account, and other types of account. You don't have just an account being created. Okay. See, this is similar to in our real world also. We have a vehicle class. No one just creates a vehicle. We have the types of vehicles, right? And objects which are created are of the subtype of vehicle. So if you want to have a class called vehicle, then you may declare it to be abstract. See, these are there as super types only. They would have their own subtypes. Okay. So declaring a type to be abstract means to have an object, you should have a subtype which is non-abstract. Okay. You should have a subtype which is non-abstract. So you will have to define something and some subtype of this which is not going to be abstract. So yes, if you want, we can in our example here also, yes, we could have gone back and said, okay, let's make this as abstract. Yeah. Okay. We can declare the account to be okay. Oh, we can just declare it as abstract. And if we compile, yeah, and let's compile and check this, it's working or not. Let's compile. And here, any type can be made as abstract. And a class could be just declared to be abstract. What would happen is, let's check, let's compile the test account now. Oh, this also compiles. Yeah, if you recollect, right, when we defined the subclasses, savings account and current account, we actually updated our code to not create object of the account class. So if you want, let's check the test account, the code for the test account. Okay, fine. So when we are saying new current account, AC1 is equal to new current account, and AC2 equals new savings account. There's nothing like creating a account object. Right? Okay, you can see what happens if we try to create a account object. Okay. Okay, let's have this, and let someone say, okay, AC equals new account, right? We do have a constructor, right? Okay, let's say okay, fine. Let's add this code and we'll see what happens now. Okay, so if we compile this, yeah, there's an error, and read the error. Abstract cannot be instantiated. Right, clear? So abstract classes, we declare a class to be abstract because we don't want the object to be created of that class. It's not that for this type it is blocked. Any subtype is actually you declare account, right? AC, AC1, AC2. The type is account. Fine. What you assign to them will be account or a subtype of account. Okay, fine. So you can instantiate only subtypes. Fine. So one thing, yes. So this, fine. Okay. Fine. So clear on this meaning of abstract type. Okay, any abstract type, yes, new, and that object creation straight away, no, that's not going to be possible. Calling a constructor, fine, to create object of a abstract type. Okay, fine. So first is about abstract type. So interfaces, typically, yes, we don't say new and call the constructor for an interface. In fact, interfaces do not have a constructor. Fine, interfaces do not have a constructor. Okay, fine. Okay, so first thing about the abstract is no instantiation, right? Okay, Fine. Then what is the next thing? Oh, we have also methods as abstract, right? We can have abstract methods. Okay. So about an abstract method, yes. Abstract methods, now this is another thing. Abstract methods can only be available with a abstract type. Only abstract types may include a abstract method. Right? Okay. If it's not an abstract type, it cannot have an abstract method. Right? If something is not an abstract type, it cannot be having a abstract method. Okay. So, okay, let's put those two statements, I think. Okay, so that's first thing, right? This is related to the instantiation. Okay, and second is methods can only be in a abstract type. I'm not restricting myself to saying class. Okay, fine. So yes, so this discussion includes the interfaces as well. Okay, abstract, yeah, it's applicable to interfaces. Fine. So all interfaces are abstract types. Okay, interface types, you can say. Okay, so it includes even the annotations. If you're defining an annotation, that's also an abstract type. Fine. So there's no question of saying new account or new hello interface. Yeah, we had a class interface called hello interface. No, you can't do that. You can't say new hello annotation. Okay, we had an annotation called hello annotation. And when we did that hello.java, we put all 5 kinds of items, right? All the 5 types were defined there. Okay, so you cannot just say new and create object of a abstract type. Account is abstract. You can't be just saying, okay, let me create a new object of account. You can be creating a new object of a subclass of account, subtype of the given type. Fine, clear on this? And abstract methods. Okay, so how is an abstract method different from the other methods? Okay, abstract method is the one where we only mention the method signature. And it's just the template. It doesn't have the body. Abstract methods do not have a body. Okay. I'll just put another word here. Do not have an implementation. Okay. When I say implementation, it means the method body. Okay, where we write the code. Okay, fine. Example of an abstract method. Okay, let's just try to have a typical class, abstract class. Maybe we want to have a class called vehicle, right? Okay, let's start with, so we want to have a class called vehicle, and no one just creates a vehicle object. Okay, so what we might do, okay, we might say, okay, let's have an abstract class called vehicle. Okay, yeah, Now, when I am defining the type vehicle, right, it's about a type now. Okay, the type is vehicle. What are the interactions available with the vehicle? If it's a vehicle, what are the interactions which are going to be available? What operations can I do with this type? Yeah. If it's a vehicle, then there must be a start method. There must be a start method. Okay, so let's have a fine. Start would be, it won't be returning anything. So we can have return type void. Method name is start, maybe without any parameter. But how will it start? How does a vehicle start? No, I don't know about it. Okay, I don't specify, and I'll declare this as abstract. Oh, because vehicle is abstract, yes, I can include abstract methods here. Okay, fine. I can have typical methods also, right? It's not that abstract class must be having an abstract method. There's no such requirement. Okay, we have our example already, right? We have our account class with no abstract methods, and yet we have a class declared as abstract. Declaring class as abstract means you are asking people to, if you want to use this, have a subclass. Then you will be able to create object. Okay, see, this is forcing you to inherit. Why we say this is opposite of final? Final was preventing the inheritance, no subclassing. Abstract is promoting the subclassing. When we design a class for inheritance, yes, we say we are designing it for inheritance. We want it to be inherited. We will declare it as abstract. Okay, fine. So yes, we can have a operation of start. We can have operation of stop. Okay, so you can include any number of such static methods. Okay, but since this is abstract, yeah, what would you do? Okay, another question which arises is, can an abstract class have constructor since we don't create object? No. Is there a use of a constructor for the abstract class? No. Is constructor used only for creating an object using the new, or is constructor used from some other places as well? Okay, let's put a variable in the vehicle class. Okay, when a vehicle is manufactured, let's have a type date. Okay, and say it has a date of manufacture. Yeah, and it's just like a typical class we have, right? Okay, we can have instance variable. Abstract class can have instance variables. All vehicles have a date of manufacture. Okay, and you might even provide the public method with an implementation, right? We can say, okay, there's a public method which will return a date. Okay, I may say date of manufacture, and it will simply be saying return this dot date of. Okay, so we have a non-abstract method as well in this abstract class. We have an instance variable. Oh, we have an instance variable. How will initialize it? How do we initialize? We'll need a constructor. And yeah, you can keep a protected or maybe a public constructor here. Okay. Okay. Which takes as parameter a date. Okay. And yeah. Okay, so my question here is, how is this constructor useful? When is this constructor going to be used? Is a constructor used only with new, or is a constructor of a class used from some other place also, other than saying new? Is it that new vehicle, that's a way to use a constructor, or is there some other place? Okay, we can have a subclass called car. Yeah. Okay. Yeah. So what will it have? Okay, it may add some more instance variables of its own. Okay. Okay. And then we might have a constructor here. Oh, this is not abstract. Maybe I'm not keeping it as abstract, but sometimes I might even decide to make it abstract. But let's say, okay, for the time being, yeah. Okay, so you want to write a constructor for car. Yeah. Okay. You will take parameters. One of the parameters will be a date. You may have other parameters which may be used for initializing the other variables. And what do we do here? First thing in a constructor. What's the first thing in the constructor? Right? Initialization of the other instance variables. So you see there's a place where the constructor of a abstract class is still used. Super. Okay.
So the
subclass, yes, the purpose of a constructor is to initialize the instance variables. Okay.
Or if you want a subclass of the abstract class, then you need a constructor, right?
You will need a constructor if you have instance variables to be initialized.
Okay.
And the way it has been used is initialization of the instance variables. That's the main purpose of our constructor. So your class, it's an abstract class. It will have instance variables. Fine. As opposed to this, okay. Okay, I'm now introducing even interface because they are also abstract type. Okay. So we can say public, and you can use the word abstract. Okay. And if you are writing an interface, right? So if you have some interface, okay, you are not allowed to have instance variables. See the difference? No instance variables and therefore no constructors. Okay, so interfaces do not have any time, you won't be able to have a constructor in there. Okay, fine. In fact, interfaces even do not have a non-final. Non-final static variables. So if you have a variable in an interface, it will only be a static and final. Fine. So, and another thing is initialization of the static variable has to be done with the assignment only. No static block. Initializer block typically we understand because there's no constructor. Initializer block was part of a constructor. And in fine, we call it as a static block also, right? And here, the word abstract in the beginning, which I've used, this is optional. Even if you don't declare, it will be considered as abstract because it's an interface. Okay, you may mention it to be abstract or not. Yes, it's still abstract. And so, abstract classes. Right? First is about the abstract class and the abstract method. And the rules are clear. Abstract class and the abstract methods. We basically it is an abstract type basically. And see one more thing. Yeah, maybe sometimes you are writing some methods. Account is abstract. Okay, and maybe it has some abstract method as well. Or okay, we have the vehicle as an abstract class, right? So anywhere, okay, so anywhere, suppose I have a code someplace and it says vehicle V, it's a declaration somewhere, or maybe someone is writing a method. It takes as parameter the vehicle V. Right? Yeah, you may be writing some method for a vehicle V. Okay, so V dot can be done or not. In vehicle class, start is an abstract method. In vehicle class, start is a abstract method. So what do you think about invocation of an abstract method? Allowed or not? Okay. So when you think about a type, okay, you are given a type, which operations I can perform on the type is available from that type. What are the operations I can perform on a vehicle? I mentioned about the operation called start. I mentioned about the operation called stop. Okay. So they can always be used. Don't worry about it being an abstract method. And the reason for that. Okay. See, what we have is a non-abstract type cannot have an abstract method. A non-abstract type cannot have an abstract method. Even it cannot be inheriting. Okay. So typically here, if we've been thinking about, okay, I'll go back to that car, the class car. Okay. We have this class car and we have not declared it to be abstract. Oh, but is this going to compile? Is this definition going to compile? It's not going to compile unless I override the abstract methods. Okay, I must be able to say, how does it start? Okay, some implementation, right? Okay, and also the other abstract method, I must be overriding that also. Any abstract method, unless you override it, the subclass is going to inherit, and that's not allowed. Okay, it's not allowed for any type which is not abstract to have an abstract method, whether you declare there only or you may be having it inherited. Even through inheritance, fine. A non-abstract type should not be having a abstract method. Okay, fine. Clear on this? And so non-abstract type, fine. Okay. So now coming back to this, right? If someone says v dot start, why should it work? We'll have to put all of them together now. See, can we create object of abstract type? No. Okay. We are receiving a vehicle type. What does it mean? If someone has to invoke this method, he must create an object of vehicle first. That means he is having an object of some subclass of vehicle. Vehicle is abstract, so definitely it is some subclass of vehicle. Can that subclass, whose instance is being created, can it have an abstract method which is not implemented? It would have to override the start and stop method. Otherwise, such a class was not possible. Class car, we are saying if it is not abstract, oh, then at least have an implementation for start and stop. You need to be having implementation for start and stop to be available. Only then the object could have been created. Only then it would be non-abstract. If it is non-abstract, see, by declaring abstract methods, you are ensuring, okay, in a class, in an abstract class, by declaring abstract methods, you are ensuring that any subtype which is non-abstract would have an implementation. Okay, if something can physically be created, yes, that operation would definitely be available on it, would have been implemented. Okay, so if you are having a method, it says, oh, I am going to have a vehicle as a parameter. Yes, to invoke this method, you need to be creating a vehicle object first. And when I say vehicle object, that means some non-abstract subtype of vehicle has to be there. And if it is a non-abstract subtype, it couldn't have been inheriting the abstract method. Right? Clear about this? So when we look at any type, any place, yes, what methods can be used? Just go into that, ignore whether it is abstract or non-abstract, don't get bothered by that. How can I use vehicle? Or I can use everything which is declared as method in the vehicle class, or whatever is inherited by vehicle class. All of that I can use. So from the user's point of view, okay, user of a class, abstract methods do not matter. Abstract methods matter to whom? To the one who is creating a subtype, and that too non-abstract. Okay, he has to be worried about, oh, I need to implement all these methods. You can't have something which can be created and you say, oh, it is a vehicle. You want to say it's a vehicle and you want to create it, and yet not mention how does it start and how does it stop? No. The how part is what is not mentioned in the abstract method. When I say it doesn't have implementation, how will it be done? Oh, that's missing, right? What is required? I need start, I need stop. You're talking about what, but not talking about how to do it. Okay, clear the meaning of the abstract keyword. Fine. Where abstract can be applied? Classes, methods, you can have interfaces. Fine. It's not for variables, okay? It's for, you can find interfaces are always going to be abstract. So even if you are not mentioning, it's still considered as abstract. Okay. Fine. So any questions about the abstract keyword? Basically, this abstract thing is always there, right? Like, okay, we didn't have it formally as a separate type, but someone could think, even in C language, someone could think, okay, we have this type called numeric type. Oh, we categorize it as numeric. We don't actually formally have a type called numeric. Here, it's allowing us to have a type whose objects are not there. When we were saying numeric, okay, we say numeric type. Oh, it has the subtypes. Int is the actual subtype. Fine. Float is another subtype. All int will have a addition, subtraction, multiplication, division. All numeric type will have a arithmetic available, right? Okay. But how do I add to integers is going to be different from how do I add to floating point values. Fine, they have a different algorithm altogether. See? So each one, so numeric type says, okay, I need these operations. And if it is numeric, yes, it's going to have addition, subtraction, multiplication, division. Okay, and even the modulus thing. Since division is there, you can even have a modulus, right? Okay, but yes, when it is coming to the actual specific type, they have to mention how it is to be done. For int, it is known, right? For float, again, oh, there's a different way of doing it. And each one will have its own way of doing it. Okay, super type mentions what is required. Subtype should say how it is to be done. Okay, fine. Whatever is known at the super type level, yes, that can be implemented in the super type and may get inherited and even be overridden. And we understand methods from a superclass either are inherited or they are overridden in a subclass. And so a subclass typically inherits, fine, or it would be overriding. If it is abstract, it has to be overridden in a non-abstract subtype. Fine, clear on this? Okay, fine. Then let me show you about the relationship between the classes and interfaces. This is about the super type subtype relationships, and we are talking about the inheritance relationship. Okay, typically the syntax for defining a class and the syntax for defining an interface. Okay. Okay. Okay, the relationships goes like this, right? As far as the classes are concerned, okay, for all the classes, okay, see, as far as classes are concerned, right, we have this class called object, which is the super class for all the classes. Okay, fine, this becomes the super class for all the classes. We have the 11 methods here. Okay, fine, we know about those 11 methods. Fine, and then any time you define a class, you will exactly mention one super class. Okay, if you are not mentioning a super class, object becomes a super class. So it's a typical tree structure, tree hierarchy, right? We'll have, okay, so we had the class called account here. Okay, so you may like this, you might have some other subclasses, and when I created a subclass, yes, we have maybe a subclass called current account. Okay, and so like this, you can have various subclasses. So when we define a class, we can have a something like this, right? But what about the interfaces? For a class, we'll say this. Now, how does interface, how do we relate a class and an interface? So interfaces will go as a super type for any class. Okay, so any class may say, okay, object class doesn't do that, fine, there's nothing above the object class. Okay, there's nothing above the object class. Object class is above all the reference types. Okay, any reference type you take, oh, you have those 11 methods, and any reference type has all the 11 methods. Okay, fine. So if we have an interface, let me use dotted lines for the interfaces. So you can say, okay, this will be having so and so interface. So for a class, a direct superclass is one class, but we can have multiple interfaces as the super types. Right? Whenever we define a type, we'll say, oh, what is its direct? What are the super types? While defining a type, we'll say, I want to inherit from these places. I am a subtype of all of these things. In that list, for a class, it will be only one superclass. For an interface, it will be any number of interfaces. For a class, it's not only one superclass, fine, class wise one superclass, but multiple super interfaces. Okay, let's check this. So look at the syntax now. I'll show the syntax part. So that should be better. Okay, syntax goes like this. We can say class. Okay, and then we have the class name. Okay, then now the optional part, if you don't mention, it will be nothing but extends from. So one part is, so a relation of a class with another class, and that's your extends, and you give your super class. Okay, okay, you give a super class name. So this is one thing. If you don't mention, your super class name will be object. Okay, and then we also have another one which is also optional. This is about implements. Fine. Here we have a comma separated list of interfaces. So comma separated list of interface names. So that's what we have. Okay. Right. So see, these are all nothing but super types. For a class, super type as from the classes is concerned is only one. But as far as interfaces, yes, we can have multiple super interfaces for a class. Okay, these are all super interfaces for the class. Okay, implements followed by a list of interfaces. So they will become the super types. Okay. So now within the body of this class definition, depending on whether this is abstract or not, if it is not abstract, you will need to ensure that you are not inheriting any abstract method. Any abstract method in any of the super types will need to be overridden here. Abstract methods on the super types need to be overridden. Interfaces, oh, they are the abstract types. They are free to have abstract methods. Okay, and so many interfaces you have, right? So in any of the super interfaces or your super class, if there is any abstract method, you need to override. If you are saying this is not abstract, or you keep it abstract, when you keep it abstract, then it is fine. Fine. This is about the header for a class definition. What about an interface? Okay, so for interface, typically it goes like this. When I define an interface, okay, we give the interface name. Okay, fine. And then the optional part here is extends. We use the word extends and give the list of interfaces. Okay, fine. We have typically the list of interfaces as a. So extends is nothing but for an interface, it only specifies the super interfaces. But keep in mind one thing, object is a super type for all of them. For everything, object is a super type. Okay. See, these are all types, understand them. They are all types. Fine. Okay, I was mentioning, yeah, yesterday we did one thing, which was about a clone method. Recollect, there's a clone method. And we had to do, for being able to use the clone method for our class called, we did it for rectangle, I think, yeah. So when we did for rectangle, we said, what did we do? We said it implements clonable. We made clonable as a super type. Okay, so we need to have ensured that all methods of clonable were implemented here. The clonable interface has no methods. The clonable interface which we have does not include any methods. Okay, fine. The purpose of that interface is simply to mark something. Okay, this, let's allow this to be, this is clonable. Yeah, we're just marking it as any class is there, and you're saying, okay, I would like that class to be clonable. Okay, clonable is also implemented by arrays. Arrays are clonable types. All arrays are clonable. And I mentioned yesterday that if you have an int array A, you can say a.clone and you get a clone object. So arrays can be cloned. Okay, any arrays can be cloned. Okay, the clone method is a shallow cloning. Fine. Fine. Yesterday we had seen that arrays are there, they are clonable, and the clone which is happening is a shallow cloning. Okay, fine. So now clonable is a super type for arrays. Fine. It would mean something like this. Someone says clonable C equals new int 5. This is valid. Clonable is a super type. Int array is a subtype. All arrays are subtypes of clonable. Fine. And on C, what are the methods available to me? C dot. Yeah. What are the things which I should be able to use here? C dot. What methods are there? Methods. I'm asking for methods. What methods I can use on C, on the variable C? What are the methods I should be able to use on C? The 11 methods. Object is super type for every reference type. You have any reference variable of a reference type, 11 methods are always there with you. Okay? Clear? Object class. The methods of object class always there. Fine. Interface. Yes. The type is interface. I can use these methods on that type. I have a variable of this type. I will be able to use all the 11 methods here. Okay. Someone is saying, I'm using a parameter clonable C in some method. Yeah. C dot 11 methods. Here it's all about types basically. Super type, subtype relationships are important here, and that's what was to be understood. Okay, and so typically, yeah. Okay, look at it in another way here. See, now this I'll show you in a different manner. So when we define some class C, okay, so this is some class C, okay, it will have only exactly one class from where it can inherit. Okay, this is with the help of keyword extends. Okay, it will have multiple interfaces. Okay, fine, and this is with the help of keyword increments. Okay, so while defining a class, you get the syntax from here. Okay, extends, give a class name, implements, give, you are free to use a list of interfaces. Okay, while defining an interface, so if you are defining an interface, okay, okay, if it's an interface, yes, we cannot be having a class that's not there. Okay, fine, you will not be specifying a class. Of course the object class is always there, but don't mention, not to be mentioned. and this will typically have super interfaces. So while defining an interface, yes, the keyword used here is extends. Fine, but object sits on top of every reference type. Fine, clear about this? Classes and interfaces. Yeah, okay. Fine, classes is clear, right? Abstract class, the keyword abstract, abstract method. Okay, just one more look at the abstract classes, the class hierarchy for the abstract class, and pick up that vehicle class as a class hierarchy. Okay, to just be able to see the various kinds of abstract classes. Fine. Okay, why? Well, we have understood why we have an abstract class, right? Okay, now a point here is like this. We will have vehicle as a abstract class. Okay, now subclass of vehicle, we went for a class called car. Okay, there are a few abstract methods here in the vehicle class. Fine, the class car does not add any new abstract methods. Okay, but it has not implemented. See, this is vehicle is abstract because it has abstract methods. It has abstract methods which are declared. And you can easily see, oh, in this there are those start and stop which are the abstract methods. Class car, someone decides to keep it abstract. Okay, let's have this as abstract. Why? The class car, he is not able to say how the start and stop will work. Okay, you have inherited the abstract methods. You have not declared abstract methods, but there are inherited abstract methods, and therefore this class needs to be abstract. Okay, you can have a subclass of this. Fine. Yeah. It may even be overriding some of the methods, but not all abstract methods have been overridden. Okay. Now this class, let's say, is a class called Maruti car. Okay. Now the class Maruti car has overridden all the abstract methods. Yes, for Maruti car, it's known how the things will work. All methods have been overridden. Okay, but we still declare it to be abstract. We will still declare it to be abstract, and then we have a subclass here. Okay. Maruti Zen. As a subclass, and this is where maybe you don't even override, or maybe you are overriding some of the methods. Right? Some of the methods may be slightly different, some additional things may be there. So this is typically talking about, oh, all Maruti cars, common to them, this is what is there, and everything is known. This is saying, okay, there are some additional things, so for that reason I have created this. Right? Okay, or someone says, okay, we have this very basic model which is the Maruti 800. Okay, maybe he's not even overriding anything. It's just simply inheriting. This one is abstract. This has no abstract methods, but you declare it as abstract because if you just create a Maruti car, you have the various models, you have the blueprints for this and this and this, and then what you manufacture, the objects which are created, that's what you manufacture basically, right? So what you do in manufacturing is you create objects of the Maruti Z, or it is a Maruti 800 or different models. These are the classes, and the objects which are there are actually of this. You don't create object of any of the superclass. You create object of this type. Fine. So everything above this is abstract. Clear? What is not abstract? The things for which we create objects. We'll need to create objects basically. Rest of the things can be abstract. Of course, there is this thought which is always there related to Java. It's not the way it has to be. But yes, typically one would think about the object class should also have been abstract. You can have object class could always typically have been declared to be abstract. Yeah? But that's not the way it is. Okay. Fine. Object class was fine. It wasn't declared as abstract, and therefore now you can't make the change. Okay, but yes, typically that would be an ideal thing. Okay, a few other things which are not very natural and uh, may create a conflict. Okay, is something like this, which are allowed here. Fine. What is being allowed here? Uh, okay, so object class, one thing, yes, it doesn't suit that. Yes, you have some super class which is non-abstract and a subclass is am abstract. You are not able to create object of a subtype, but you are able to create object of a super type. You are able to create a new object, but you are not able to create a new vehicle. Right? And that doesn't look correct. Okay. Okay. Another thing is about, you got the implementation of the 11 methods of the object class, and there are those implementations which are available, but then a subclass, fine, okay, fine, but then a subclass here okay, so a subclass here, for example, vehicle here could be doing something like this. I want to have a public and abstract. So because it's an abstract class, it's saying, oh, I can have an abstract method, okay, which returns string. Name of the method is toString. And this is acceptable. A method having an implementation in a superclass, the subclass is overriding it and making it abstract. This is being allowed. Okay, it doesn't sound good, but yes, this is what is working in Java. Fine. normally you will override because you want to do something additional. Okay, a subclass would add something more to it, but this one says no, not allowed here. Fine. Yeah. See, from the concept of inheritance which we normally have, typically what we always say is a subtype will have more functionality compared to the supertype. It adds to it. It's not supposed to remove something which was available to me. Right? Supertype says, okay, it's available, but the subtype says, oh, it's not available. Okay, so these are some of the places, right, which looks odd from that point of view. Okay, fine. So non-abstract method, abstract subclass is okay. I'm making it abstract. Okay, fine. Clear on this? I'm just explaining a few additional things here. Okay, fine. Fine. Okay, now, so this is fine. So next exercise part. Exercise was, I think I've done that part already, declaring the account as abstract, because we don't want to create object of the account class. Okay, we don't want to be creating object of the account class. Fine, so clear with this? Okay, now one more thing about the interface. Okay, interface, interface, lot of things are still to be explained. Oh, what is an interface? Yeah, collection of abstract methods. Normally, that's the concept you have. Okay, fine. It's just a type. Fine. Interface is just typically a type. Normally, yes, normally for defining a set of abstract methods, right? Okay, that's how it was always being used. Okay, fine. But then from Java 8, there are some more changes which have come. Okay, so let's look at what are the members which go in a interface. Let me push that thing here. Okay, so how does an interface look like? So yeah, we saw that, right? The header was, you have the modifiers like public and abstract, and then you'll say, so then you might use the word interface, give the name of the interface. Okay, there's a name. Okay, you have the typical thing like extends, and this is list of interfaces. Fine. The next thing which comes here, what are the members which go? So it'll say, oh, we have variables. Okay, two types of things basically, methods and variables. Constructors and blocks are not there. Fine. I'm not considering the subtyping. Okay, no, I'm not considering the subtypes here. But yes, we do not have constructors, we do not have the methods. We can have the type definitions like class, nested types, right? Nested types can be there. So currently I'm not looking at the nested types at all. Okay, so from the members point of view, an interface can have variables. Fine. So we have the variables and the methods. Okay, no constructors. Right? So variables and methods. If it is a variable, there's only one thing about a variable declaration. Fine. Fine. All variables are static and final. Even if you are not mentioning, it's a variable declaration inside an interface. it would mean static and final. You may not be declaring it as static and final. Still, because it's a variable coming in an interface, it means it's a public static final. Okay, it's public. Fine. Typically, prior to Java 8, or rather Java 9, I should say, prior to Java 9, all members in an interface were public. If you may not mention them to be public, but by default, all the members are public. And only thing you could declare was, you could declare it public. You don't declare it public, I consider it still as public. So you were not allowed to say protected or private as a modifier for a member of a interface. All members of an interface always public. Okay, fine. Now coming to the methods, right? Methods in an interface. All methods in interface were abstract. By default, they will be abstract. You may not mention abstract. It's a method in an interface, that means it's an abstract. That's the way till Java 8. Fine. Fine. In Java 8, what changed? We have what kind of methods? Methods were 3 types. If you don't mention, right, or you mention by default, default was abstract. So even if you're not mentioning, it would be considered as abstract. Okay. Or yeah, what we did in our hello.java, we defined a static method. Okay. So we could always have a static method now. Fine. From Java 8 onwards, interface can include static methods. Okay, interface can include static methods. Now another thing which happened. Okay, I'll explain with the help of the need, how the need arose for the another type of method. Okay, now Java keeps the backward compatibility as its selling point. And typical thing about Java is, yes, it is it's been developed for so many years, it's existing. There are so many versions, but a new version tries to maintain maximum possible backward compatibility. Your old code should work as it is in the newer versions. Okay, and they were maintaining this all the time. Now just think, here is an abstract interface, is an abstract type. Okay, here's an abstract type for which is in the library. Now this is related to the library. So we have so many interfaces even in the library, right? And typically you code for them. So for example, one of the interfaces is, let's say, an interface called list. Okay, so we have one interface called list. List was a data structure basically, right, which would maintain objects. Okay, number of objects could be managed in it. Fine. And they would have index position, right? List is maintaining objects with the help of their index positions. Okay, so list is an interface, but so we have various classes everywhere. Everyone uses the type list so that we can use all the methods available in the list. Now it so happened that yes, list was there in Java 1.2, and that time they had decided a set of methods. Fine, they were all abstract methods only in a list, and then it was felt, no, I think I'm missing the sort method here. They missed out on a method. Can I add a new method in a newer version and say, oh, it's going to be backward compatible? I want to add a method in the interface in the newer version. Can I add? and keep it backward compatible as well. The sort method could not be added for so many versions. How do I add? Because if I add a method, any class which was implementing this interface, that would break. Because they won't have the implementation for sort. And earlier you were saying oh, list has only these methods, and now you're adding some new method which is abstract. So how do we do that? So, oh, anyone who doesn't have, right? I want to add a new method. So anyone who doesn't have want to have an implementation done for him, fine. Who doesn't want to implement this new method? The old implementations of the list, they need a sort. They need to be having a sort, but fine, sort should be able to work there. So what was added was say that, okay, we'll write the implementation, some default implementation, and therefore the method was the keyword default has been used here also. Default, keywords have multiple uses. Default has a use in the switch case. Oh, we have a default being used here also. So we have a method to be declared as default. And then you can write the how part for such a method in an interface. So interface can now include default method. Fine. Why the word default had to be used? Because in interface, if you don't declare anything, it would be considered as abstract. I mean, that was the rule prior to Java 8. So they said, okay. So now normally the method, normally in a class when we write a method, fine, we don't declare anything. That means, yes, you will have an implementation done for it, right? Here, you want to write an implementation in an interface, mention it as default and then put it. Because if you don't mention, it will think this is abstract. And so, fine. So methods default is abstract, and you may otherwise be declaring it static or default. Okay. And so two additional kind of members in the method list for interfaces from Java 8. Okay. And typically, if we have a method, right, in your method, there might be some code which keeps on repeating. Right? So these are some codes which you may use as a private method. Because it repeats, you have to do it so many times. Don't write the code again and again. Okay, you may put it in a private method. Okay, and therefore from Java 9, and they allow a static or a default method to be declared as private also. Only private, okay, not protected. Fine, you may have a private method being used from, so it's a private static method being used from a static method. Fine, a private static method may even be used from a default method. Fine, you may have a private default method, but that can only be used from a default method. Okay, so private members are only for static and default methods. Other methods in an interface always public. Okay, fine, clear on this? Okay. Fine. Okay, so yeah, any questions? Yeah. Fine. Otherwise, we'll continue tomorrow then.